Hi, this is Group 3 and I'm Chen Xiangyu. The project of our group is bank marketing campaigns. As you can see, our presentation has three parts. The first part is explanation of purpose. We all believe that we should identify the process of bank marketing campaigns first, and we also find after using marketing methods, we may have three different results. But the red results are acceptable. That's because we do not lose any potential clients in these two situations. But the black result, the false negative result is very bad because our potential clients are not in our data set. And based on the purpose of our bank, which is minimize costs and maximize benefits, we should know that marketing method will consume our resources. So we should allocate resources to our potential client. That means we should use our model to figure out who is our potential client. FN results, which is false negative results, is unacceptable. So we should optimize for recall to avoid this situation.
Now let's move to the modeling part. First, I'm going to do the analysis of the logistic regression. A correlation matrix was used to identify if there was strong correlation between variables, where most variables were found to have no significant correlation. Thus, the predictive model was built without removing any X variables. A 70-30 train and test split was applied to recommendedly split the dataset into training and testing datasets. All X variables were standardized so they are on the same scale. A constant column of 1 was added to allow the capture of the constant variable in a linear model. After the dataset was fully prepared, a logistic regression model was built upon the test set. Based on the result, there are certain variables with significant p-values such as job blue color and education university degree. We found that this coefficient EMP variable rate has the largest absolute value, so it has the greatest effect on Y. The testing set was fitted on the model and accuracy, precision and recall of the model was compared. We can see that the accuracy is about 90% and the precision is about 65.6%, and the recall for the Y values as yes is 0.39, which means 39% of the yes answers were accurately predicted, which is a somehow smaller number. The predicted probabilities indicate that the model is more likely to predict for a negative value over a positive value, but the recall rate and accuracy rate are low. We also changed the threshold of the classification to compare the accuracy of model under different thresholds, where with the increase of thresholds, the precision reduced gradually while the recall rate increased. And the area under the ROC curve was also plotted, which suggests that at a false positive rate of around 0.2, the true positive rate can be optimized at around 0.9. From the picture, we can see that the ROC curve is located in the upper left corner, which means that the model can achieve a high true class rate at various thresholds while maintaining a low false positive class rate. Lastly, regression model using lasso and ridge method were performed to compare for the difference, and a cross validation were performed. The average CV scores are 0.91 and the standard deviation is 0.0044.
Now let's look at the decision tree model part. As Y is a categorical variable, we decided to make a classification decision tree and see how the performance was. Therefore, we choose all the dummy variables fx, build train set and test set. Then we started to build the decision tree model and generated the image of decision tree model. However, we found that there was only one leaf, which class equals to 1. Although the confusion matrix showed that the accuracy rate was about to 0.88, recall rate was only about to 0.22. After that, we went back to the data and checked the number of y equals to 0 and y equals to 1. We found that y equals to 0 could be 4 times more than y equals to 1, which means that the data was imbalanced and had impacted the decision tree model. Therefore, we use IMB-learn to make the data to be balanced. At the end of variable processing, the y equals to 1 was as same as the number of y equals to 0, which was 3096. We named the new variables with YRES and XRES. After generating the decision tree, we found that the plot did better on showing class 1 and class 0. When it came to the confusion matrix, it showed that the accuracy rate decreased a little bit to 0.83. However, the recall rate increased much more to 0.54. Therefore, according to the confusion matrix, we decided to choose the second decision tree model. At the end, we wrote a function to print the result of the decision tree model so that we can get some commercial insights. Next is the suggestion part of decision tree model.
After the analyzing of the decision tree, I have some suggestions, and can be divided into 3 parts. The first one is targeted marketing campaigns for specific months. Both marketing efforts in specific months considered ramping up marketing activities in September, July, and December, as customers in these months appear more likely to subscribe to fixed-term deposits, design special marketing plans and promotions for these months to attract more subscribers. The second one is the education level as segmentation criterion. Target customers based on education background. According to the analysis, customers with college degrees or high school education levels are more inclined to subscribe. Customize marketing messages and channels to address the specific needs and the interests of these groups for personalized marketing. And the third one is optimize communication channels. Utilize effective contact methods. Analysis suggests that phone contact is associated with higher subscription probabilities in certain cases. Consider using more phone marketing for customer segments to prefer phone communications, while optimize communication strategies across other electronic channels to improve the coverage and the conversion rates. That's it. And welcome my roommate to introduce the ANN.
This part, let's move on, use the modeling about the artificial neural network. For the second one, also very important, we do the data preparing and the pre-processing. And the second one, I will do the data scaling. We use the put our input, the different numerical data into a standard normal distribution. The third one, I will build the model, use the different threshold and check their model's performance. For the first one, I load the data and I find our data is imbalanced. So I use a very new method is for the imbalance over random over sampling. I resample our data and focus on the majority data set of our output target variables. So finally finish this resample, we can see my majority data and the minority data have equal weighted in my modeling data set. And the second one, I use a very, very good method to identify the more optimal learning rate and the optimal hidden layer sizes. This is very important two parameters in build my artificial neural network model. And the optimal hidden layer sizes is for 9.9 and the learning rate unit is 0.1. Finally, I use a for loop to put the different threshold in my model. So the for loop result shows when the threshold is 0.4, they have a very good accuracy score and recall score together. So that means when they fit to our business purpose, that means this model is very good for predict the customer who will subscribe next term deposit, and very good to minimal the false prediction. That's very good for our to predict the next subscribe deposits customers and allocation my resource very efficiently. That's all. Thank you.
In this part, I use a sample model to evaluate artificial neural network model. I use for loop to run back-in classifier for 5 times in order to assess the stability and the generalization ability of the artificial neural network model across the different training data sets. And the result, you can see, especially the average recall is pretty good. This part is conclusion and suggestions. After all, we found the performance of artificial neural network is the best. That's because we want a higher recall. So we decided to use ANN model for our client classification. And we highly suggest that after our client classification, we should implement some strategy for these targeted potential clients to improve our services for them. That's all. Thank you.